Hello, my name is Sydney Gotro. I'm the instructor for the 111 online lab. Today I'm going to talk about the making measurement lab. It's the first lab after you complete the introductory assignments just to get through HOL's requirements. So this is the vernier caliper. I'm going to change the camera so you can see. This focuses pretty well. Let's see how it goes. So these are the calipers. The instructions in HOL first tell you to record the smallest interval. Let's see. Here we go. As you can see on the bottom here, it goes from 0 to 150 millimeters. So the smallest interval on the main scale, so the scale that doesn't move, is 1 millimeter. The top here uses inches, so we're not going to worry about inches. We're going to stay in metric because we're doing physics. So the least interval is, our smallest interval is 1 millimeter. That's what they call S in HOL. The next thing they do is tell you to count the number of divisions of the vernier scale and record as N. So the vernier scale is the thing that moves here. They're talking about the number of divisions here on the bottom. So you can see it's numbered 0 to 10, but in between the 0 and the 1 and all the integers is another little half mark. So there's actually 20 different ticks. So N for this caliper would be 20. And then once you have those two numbers, you can calculate the least count of the device using the formula least count equals S over N, where S was the smallest interval, which was 1 millimeter, and N for this scenario is 20. So 1 millimeter over 20, you get 0.05 millimeters. And that's what this number on the caliper means. This tells you what the math is that we just did. So once you do that, you're going to start making measurements. One of the next confusing things could be what they talk about, the vernier coincidence. So what this thing on the bottom does down here is whenever you make a measurement, you start with the main scale. So you see where the 0 lines up. Let me see if I can raise this up a little bit. Glare. So you see where the 0 lines up. You see it's in between the 25th and the 26th millimeter. So that tells you it's 25 and something millimeters. So to get the something, you use the vernier scale of the calipers and go left to right and see at which one of these little ticks first lines up perfectly with one of the ticks from the main scale. So we can see the 0 doesn't, obviously, because that's why we're doing this. If the 0 was perfectly on something, it would be exactly 25 millimeters, for example. The next tick doesn't line up. The 1 almost lines up perfectly. The 1.5, I say it's off just a smidge, but the 2 lines up really, really good. So that tells you that out of the 10 units, or you can look at it as 20 ticks, however you want to look at it, 2 out of 10 or 4 ticks out of 20, 20% of 1 millimeter is the decimal. So in this scenario, it would be 25.2 millimeters. So kind of confusing, but that's how these very cheaply made calipers work. You can buy digital calipers that will just tell you the number, a lot easier to do, but so they also have some examples in the questions to help you make some measurements with pictures they take where the scale isn't perfectly on a number. So in exercise 1, you'll get the different dimensions of the diameter, the height, and from that you can calculate the volume of this. And then once you get the volume, you use your little scale. A little scale, which should have a battery in there. Open the battery and then unravel the plastic, put it back in, and then get the weight. And then from that, you can get the density of this acrylic cylinder. Um, and density, they give you all the formulas. Density is just mass over volume. Then you do the same thing for a marble. They give you the formulas to get the volumes of these different shapes. And then once you get the densities, the marble should be made of glass, so you should get a density of roughly 2.7 grams per centimeter cubed. And then the cylinder, if it is clear looking like mine, it should be acrylic, and you should get around 1.18 grams per centimeter cubed. So there's those numbers. And then once you get that, for the lab report, in your results section, you can write a percent error. So in the results section, you'll write what your results were. So just talk about one of the shapes. You can talk about the cylinder. Say we got a density for the cylinder to be let's say you get 1.2 grams per centimeter cubed. The accepted value could be 1.18 grams per centimeter cubed, and then you can calculate a percent error. Percent error is the difference over the accepted times 100. So if I said, I forgot the number I just said, let's say I had 2.68, accepted was 2.7. Absolute value, so you always end up with a positive value on top over accepted times the 100%. Then you plug that in your calculator and get a percent error. And then for validity in the results section, you can say if your percent error is less than 5%, valid, and if greater than 5%, invalid. It's okay to have an invalid result. Just state whatever it is. That's not a problem at all. In the conclusion section, you'll just restate the two numbers. Your uh, density of glass was 2.7, and the accepted, or vice versa, density of your glass was 2.68, the accepted was 2.7. Got a percent error of say 3% for a valid result, or let's say you got an 8% for an invalid result. You could then talk about why you think it was invalid, like what was off with the measured values to get that result to be off. So it was either the volume measurements or it was the weight measurement. So try to talk about that a little bit in the conclusion section, what you think about that. The purpose section, I didn't talk much about that. Let me move this camera back to me. The purpose section, you're going to look for three main things: measured values, calculated values, and then what was the physical principle or equation used. When we're talking about the density of something, you measured, for example, let's talk about the cylinder. And that's why you should just do one shape so you don't have to have a bunch of listed measured values, even though they're not much different. For the cylinder, you would talk about the height, uh, the diameter, and then use we won't go there yet. That would be that. Then your calculated values would be the volume of the cylinder. And then also your measured value would be the weight of the cylinder. So measured values, kind of repeating things: weight, diameter, height. Calculated values would be volume and then density. And then the equations you use would be density is mass over volume, and then the equations for whatever shape you use. If it's a marble, it's the volume of a sphere. If it's a cylinder, it's the volume of a cylinder. So that covers the purpose. For the introduction, just talk about how you got those measured values. So talk about what you did with the calipers. You don't have to get very detailed, just one or two sentences about what you did. Talk about using the scale to get the weight in grams. And then talk about any assumptions. So for assumptions, you can assume that the material is homogeneous throughout. If you say that assumption for the marble, you actually see there's some dye, or I don't know if that's an object or there's little air bubbles, but if you assume this is homogeneous throughout, and then you get a density that is too small, you can say in the conclusion that you had an invalid assumption, and that there's actually air bubbles and something else in here that could be less dense than glass that got you a density too small. Which means that this, when you weigh it, it would weigh too less because it should have been a little bit heavier if all the air bubbles were filled with glass or whatever. So, and then for all the other sections, you just export your PDF from HOL and include that as a second file, or you can attach it in between the intro and the results section, or put it on the end. However, you can get it in there. It really doesn't matter. We prefer it as one file, but we also realize it's sometimes difficult to get one file from multiple PDFs. So if you have issues, just submit multiple PDFs under the one submission. So I think that kind of covers everything. Oh, one more thing, you'll also complete the second exercise in HOL, which is about uncertainties. It's very quick. You need a partner. You're both going to like drop a ball and time it till it hits the ground, and then do some quick math with it. But complete that, but you don't have to write anything about that. But also include that PDF with your lab one report. So that's pretty much it. If you have any questions, send me an email at sydney.gotro@usm.edu. You could also email your TDA. Your TA has regular office hours online, as posted in the syllabus. And then you can just email me and we can meet online whenever we need to. So, bye.